Can't get your whitefish.
Oh, I got it.
Can you follow it? I don't know. Seriously.
It's a good job.
You know,
Well, you get like steak. I was kidding. I haven't seen cannonball. Don't think
they say it's pretty fun. Oh, I noticed that those
Oh, 7 o'clock. Welcome, everyone. If the microphone works. Hey, quagga?
Not sure. Find out.
Yeah, it's on.
There you go.
You don't need them both.
We didn't want to listen to you.
Yeah. Who invited you? Welcome everyone to Crossroads in the Fishtails Lecture Series. Tonight we have a really great talk on the status of whitefish in Lake Michigan and Green Bay. And this is sort of the third in this list of our talks this year. The first one was opportunities to restore prey fish in Lake Michigan and the Great Lakes. Then I hope many of you got to see All Too Clear, the film documentary on the effect of quagga mussels on the system. During that movie, if you got to see it, there was a lot of talk about whitefish and how they weren't doing very well. And so that was focused on some of the tribal fisheries up in Lake Huron, where they've been especially hit harder than even Lake Michigan. But when you heard it, it's sort of like, oh man, whitefish are on the skid. So I thought it was appropriate then to get the local DNR folks that manage our fishery to come in and tell us the status. Because actually, as you'll find out, in Wisconsin waters has some of the best holdout whitefish in the Great Lakes. But with that, I want to also mention in a month, on March 27th, we'll have Jonathan Piaskowitz from the Menominee Nation talk to us about how they manage the fisheries on their waters there. Certainly, Menominees have a history to this area. Coggin typically reminds me of that when she talks about her archaeological digs and so on. So it'll be an interesting chance to see how the Native Americans approach their resource management. So please don't miss that. It should be really good. And then to finish up the program on April 17th, we'll be back corners from the Fish and Wildlife Service to talk about mass marketing. Especially in the last few years, they focused more on steelhead, which they didn't do originally. So they'll have some new secrets from the mass marketing program, and we'll hear what that new stuff is. So don't miss that either. So with that, actually tonight is kind of a 2-for-1. All our advertising material said Scott Hansen was going to be here, but he also then realized after he said yes that his son's last basketball game is tonight. And I said, well, that's more important than doing the fish sales, especially since we can have his boss, Nick Legler, come and give us talk for him. So Scott did put together this whole presentation, and actually Nick and Scott and I met yesterday before. But Nick graciously said that he'd step in and do that. So with no further ado, here's Nick Legler, the supervisor of the DNR station.
Okay, I'll start off just by saying thank you to Mark, both for coordinating this Fishtail lecture series and also for the invitation to Wisconsin DNR to present today. So my first job in fisheries management was actually working for Mark back when he was with the U.S. Fish and Wildlife Service. I worked as a STEP employee, student temporary employee for about 3 years while I was an undergrad at UW-Stevens Point with Mark. I'm originally from Seymour, Wisconsin. I bounced after my undergrad, I went to the University of Windsor in Ontario. I was in Green Bay, Madison, Escanaba up in the UP. And then eventually I landed here in Sturgeon Bay. And interestingly, I live about 2 blocks from Mark. This is at least the 4th outreach event that I've coordinated with Mark on. So the fact that we first crossed paths 22 years ago, when I was just a student, I very much appreciate the opportunity to continue working with Mark here today. Let's see, it's not advancing. There we go. So I worked as a fisheries biologist here in Sturgeon Bay for about 10 years. I specialized mostly in Chinook salmon and steelhead management for Lake Michigan. I also worked with inland fish management for Door and Kewaunee counties. And then about 3 years ago, I transitioned into the supervisor position for the Northern Lake Michigan fisheries team. And as Mark said, Scott Hansen was originally scheduled to give the presentation today. Scott is a fisheries biologist with the Wisconsin DNR. He's been with the department since 2007. And Scott Hansen specializes specifically in whitefish and smallmouth bass. But Scott accidentally got double booked tonight. So Scott's son, Bryce, is a senior this year. He is on the varsity basketball team for the Clippers. Today is his last regular season game, and it's also senior night. So Mark, Scott, and I all agreed that it was important for Scott to be with his son. So I'm going to step in and give the presentation today. I do want to thank Scott for all the effort that he put into putting together a lot of the data and the figures that will be presented here today. Scott has 18 years of experience working with whitefish locally. So he's very well versed in the background, the history, the ecology, the management of whitefish. This is the talk I've ever given on whitefish. So I just want to acknowledge that the content is going to be very similar to the presentation Scott did, but I did tailor the presentation a little bit, I guess, to my comfort level for tonight. If you are interested in hearing directly from Scott, we do have a Lake Michigan whitefish management webpage with the Wisconsin DNR, and there are several past presentations recorded that are on there that have been given by Scott with a lot of good presentations and information. So I'm going to start off just with some simple facts and information and background on Lake Whitefish, just to kind of highlight the importance of Lake Whitefish, both for the ecosystem and the fishery, as well as our local communities. Lake Whitefish are distributed throughout the Great Lakes. They are native to the Great Lakes. And this is just a simple list of some native and non-native fishes in Lake Michigan. And I show this again just to highlight that Lake Whitefish are native. They have a very long history and importance to Lake Michigan's ecosystem as well as Lake Michigan's fishery. And then I also show this list to show kind of an interesting similarity between Lake Whitefish, native lake trout, and non-native Chinook salmon, coho salmon, brown trout, and rainbow trout. These fish are all actually part of the same family of fishes, the Salmonidae or salmon family. So even though lake whitefish may look different than a Chinook salmon or a trout, they may behave different. They actually are in the same family of fish. And one unique characteristic of this family is that they all have a adipose fin on their back near their tail. So Chinook salmon, lake trout, brown trout, they all kind of operate in a different part of the Lake Michigan ecosystem. They tend to be higher level predators. Adults feed mostly on midwater bait fish, and lake whitefish are quite different. Lake whitefish tend to be more benthic. They feed on a lot of aquatic invertebrates, but nonetheless, they both have very important parts in the Lake Michigan ecosystem. Lake whitefish diets vary seasonally and by location throughout Lake Michigan, but generally lake whitefish eat fish eggs. They eat mysids, which are small shrimp-like crustaceans, gastropods or snails, fish, mussels. Those are all things that are important to the diet of the lake whitefish. If you look at the mouth of the lake whitefish, it's somewhat downward facing. And again, they do a lot of feeding at the bottom of the lake. Some of the food sources, round goby, mussels, they are invasive to Lake Michigan. So the lake whitefish has kind of a change or adapted to eating some of those non-native prey items. And anglers have kind of adapted to and figured that out too. One of the common baits fishing for lake whitefish is something fished on the bottom that almost resembles or mimics a goby as you're fishing for these whitefish through the ice. Historically, Diaperia, which is the amphipod pictured here, was the primary native and extremely high energy food source for lake whitefish. After the invasion of zebra and quagga mussels, Diaperia were essentially wiped out from Lake Michigan, and that has contributed to some decreases in both the growth and condition of lake whitefish in Lake Michigan. So whitefish can live to be relatively old. This is actually a photo of an otolith, which is the inner ear bone structure of a whitefish. And the growth rings or annuli on this structure can be counted to estimate the age of the fish. Fisheries technician Derek Apps just very recently aged this whitefish, and it was actually estimated to be 32 years old. If we look at average ages of whitefish in Lake Michigan, this is the average age per year for whitefish that were collected from commercial trap nets, in the first one's Lake Michigan trap nets, the second one is Green Bay trap nets, and then the third line there is the sport fishery from Green Bay. And in 2021, the average age of these whitefish ranged from 11 years old in Green Bay to up to 17 years old in Lake Michigan. So in Lake Michigan, on average, the whitefish that we're sampling tend to be about 5 years older than the whitefish that we're sampling in Green Bay. Generally, the Lake Michigan fish right now are running bigger and older than what we're seeing in the Bay of Green Bay. In terms of life history, whitefish spawn in the fall, typically around November. They spawn on rocky reefs and shoals as well as in tributaries. Their eggs actually incubate throughout the winter, and then they will actually hatch out in March or April. So there's a lot of factors that are important to the recruitment or the survival of those eggs and those fish. That's the case for any young fish. If you think about an egg or a small larval fish, there's a lot of things, if they don't go right, those fish might not survive. Water temperature, food availability, predation. So for whitefish, actually one of the real important things is ice cover. Lake Michigan can be very turbulent. There could be a lot of storms, and ice cover actually will protect those eggs as they incubate throughout the winter. Spring temperatures can also be important. They impact the hatch timing and the food availability of those whitefish. So when you think about in the respect of climate change, and you think like last winter when we had almost no ice coverage, things like that can have a pretty big impact on fish like whitefish. For whitefish, bays and protected areas are particularly important to provide kind of nursery areas for whitefish when they're. And historically, North and Moonlight Bays were kind of considered Wisconsin's cornerstone stock for whitefish. These bays are located on the Lake Michigan side of Northern Door Peninsula, and they provide a lot of that rocky embayment type habitat that are very important for whitefish. This habitat within this area historically supported a very large portion of the production of whitefish in Wisconsin waters of Lake Michigan. Historical management has been based largely on this stock, and this area has been particularly important for the commercial harvest of whitefish as well. So if we take a look at the commercial harvest of lake whitefish, this is harvest throughout all of Lake Michigan, and then Lake Huron and Lake Superior as well, all plotted separately by commercial fishers. This is the annual harvest in millions of kilograms by year. And we see some basic trends. So in the 1950s, we generally saw a decreasing harvest of lake whitefish in the Great Lakes. That was largely attributed to the sea lamprey and high mortality rates of whitefish during that time period. But following that, for the past several decades, thanks largely to sea lamprey control, we saw improvements, and we actually saw some of the highest of whitefish that we've seen consistently in the history of the fishery. Now, in recent years, we have seen a slight decline, but overall, for the past several decades, we've had relatively high commercial harvest of lake whitefish, and Wisconsin waters particularly are contributing a pretty big portion of that harvest. So lake whitefish, they are the most important commercial fish remaining in the Great Lakes. They have a very long history of importance in Wisconsin. Across all the Great Lakes, Lake Michigan accounts for roughly half of the commercial harvest. The dockside value is estimated at over $10 million. Whitefish are consumed fillets. Their roe is a very high value export, their eggs. And there's actually a program going on right now outside the DNR called 100% Great Lakes Fish that is looking for different ways to utilize whitefish in the commercial industry. So typically a fish fillet of a whitefish represents about 40% of the biomass of that fish. And there's about 60% that's commonly discarded, sometimes used as animal feed or fertilizer. This 100% Great Lakes Fish Initiative is essentially looking for ways to utilize all parts of the fish. So pharmaceuticals, collagen supplements, fish leather, as you can see in this picture, are some of the things that are being experimented with to potentially utilize these different parts of the fish. So lake whitefish, they're important. They're important for the county and beyond. Locally, I think it's very evident in the local fish markets, menu items at restaurants, fish boils. It's important in the sport fishery, both for independent recreational anglers as well as guides. And really there's a lot of reasons that lake whitefish are important. So next, I want to just highlight some of the kind of important big picture trends when we're looking at whitefish populations, particularly Lake Michigan versus Green Bay, and then also looking at the status of Lake Michigan more generally. So kind of keeping with the theme of tonight's fishtail lectures, there really is two, I would say, very distinct tales or stories to tell with Lake Whitefish when you compare the Bay of Green Bay to Lake Michigan proper. And I'm going to start off by talking about Green Bay, which is really kind of a shining star right now when you compare them to Lake Whitefish throughout the rest of the Great Lakes. The slide here is cut off a little bit. Can't quite see the top.
Have to give that. No, that's not working. I wonder if I can hide something. That doesn't do anything. Okay, guess I can't fix it. That should be there.
So Lake Whitefish historically did support populations or spawning runs in Green Bay tributaries. This was especially true in the Menominee River. During the mid-1800s, there was very large runs of whitefish and herring that occurred in the Menominee River. However, these populations quickly declined, and they were essentially extirpated or eliminated from areas. And this was largely due to sawmill operations and industry, as well as overfishing. No, there we go. So this is just a picture that shows lumber industry on a river, and you can see how and big of an impact some of these things may have had on fish and fish habitat. And this particular quote, which I can't read all of it here, essentially says that these operations are having a very injurious effect on the fisheries, and the sawdust that covers the feeding and spawning grounds is having a real big impact or problem on the fish. So again, local whitefish populations is essentially extirpated by the late 1800s. And if we fast forward 100 years to the early to mid 1990s, starting to see signs of recovery of the lake whitefish. So fisheries biologist Tammy Paoli out of Peshtigo, as well as the Peshtigo DNR team, really conducts electrofishing runs on the Menominee River for a brown trout survey. They're targeting brown trout. This is an electrofishing survey on the Menominee River. It's conducted in the fall. And again, they're targeting brown trout. But in 1995, they started to see incidental catch of lake whitefish in their brown trout survey. And by 2005, they started to see many whitefish showing up in their electrofishing surveys. So we originally started to see these whitefish showing up in the Menominee River. Soon after, we looked in the Fox River, started to see whitefish there, Conto and the Peshtigo rivers. And then there's been some evidence of whitefish spawning on Larson's Reef in Green Bay. So I think there are many possible explanations as far as why we started to see these whitefish showing up in the rivers. One is improved habitat. One is an expansion of remnant stock. So maybe there was always some whitefish left in Green Bay in the rivers, but they were just at very low abundances and we didn't really notice them. And then lastly, it could have been spillover from Lake Michigan. So there was very high biomass of lake whitefish in the 1990s and 2000s in Lake Michigan. Perhaps some of those fish started to kind of spill over into Green Bay and start to recolonize the rivers. So I do want to emphasize the importance of habitat for fish. So the Clean Water Act significantly expanded in 1972. This essentially provided the basic structure for regulating discharge of pollution into waters. Under the Clean Water Act, there's been several implemented programs to help with pollution control in the waters. The area of concerns happened a bit later, but I still want to mention just to emphasize the importance of habitat in the Menominee River. So in 1987, there were areas of concern designated throughout the Great Lakes. These were areas that were in need of special attention for restoration. In Wisconsin, we actually have 5 areas of concern, including the lower Menominee River. And after decades of work and partnerships with a lot of people and groups, sources of pollution in the Menominee River were cleaned up, cleanup goals were met, fish and wildlife habitat restoration projects were implemented. And in 2020, the lower Menominee River was delisted as an area of concern. So going back to Tammy Paoli and some of her surveys, she also does trawling in Green Bay in the summer. This particular survey targets juvenile yellow perch, but she started to see juvenile whitefish showing up in those trawls. You can see the whitefish that she's caught throughout the years. 2009, 2015 particularly were relatively good years for young of the year production of whitefish in Green Bay. So if we look at an estimate of biomass of whitefish in Green Bay, we see a growing or increasing biomass from 2007 to 2013. And as a fish biologist, that's pretty exciting to see, especially when you consider the populations were extirpated. We now see an expanding and growing number of whitefish in Green Bay. Recently, we've seen somewhat of a leveling, almost a decline in biomass. So this is important. And I think it's something that we'll have to continue to monitor pretty closely. So if you look at Lake Michigan proper, you do see a much different trend than what we're seeing in Green Bay. So again, this is the estimate of biomass in Green Bay for whitefish in the green line. And then this is the estimated biomass in Lake Michigan waters, in Wisconsin waters of Lake Michigan. So I do want to acknowledge that these are estimates of biomass. They're based on statistical catch-at-age modeling. So the reality is Lake Michigan is extremely large. It's extremely complex. Like we're never going to know definitively how much whitefish are out there. But what we can do is we can collect a lot of data. We can collect a lot of surveys as listed here. We can look at data independent to see what individual data sets are showing for trends. We can also combine all of that data into a model that gives us a scientific estimate of how many alewife are actually out in the lake. And when we do that, we see a decreasing trend in biomass over the last 20 years for lake whitefish in Lake Michigan. Notably, the very similar trends have been seen throughout all other areas of Lake Michigan by other states as well. So this seems to be a trend that's happening throughout the Lake Michigan basin. So in addition to that, I'd want to highlight some similar trends in size and growth for whitefish. So this is the average weight of whitefish in pounds by year. And I'm just gonna break this data set down a little bit and focus in on, so this is in 1997, an age 6 whitefish on average was 3 pounds. If we fast forward 20 years, an age 6 whitefish on average now is less than 1.5 pounds. So they're growing slower. It takes twice as long for a whitefish to get to 17 inches now. 17 inches is the size limit for the commercial fishery. And again, the fish are generally growing slower. So if you look at Lake Michigan proper, we've got reduced biomass of whitefish. We've got slower growth of whitefish, generally larger, older whitefish. And we'll ask why. And Lake Michigan is such a large, complex system that it's really hard to pinpoint any one factor that's driving these patterns. The reality is there's probably numerous factors that are coming into play. But I think invasive species and the impacts they've had on the ecosystem are probably one of the biggest reasons. So there are over 180 invasive species, fish, plants, and vertebrates in the Great Lakes. They've greatly changed the Lake Michigan ecosystem. They compete with native species. They've created challenges for fisheries management. And one that I want to particularly highlight is the zebra and quagga mussels. These are invasive. They're non-native to Lake Michigan. They came into the Great Lakes likely through ballast water from the St. Lawrence Seaway. And they've expanded throughout Lake Michigan. So this shows 1994 to 2010. The darker the color, the more dense the quagga mussels are on the bottom of the Lake Michigan. So right now, these mussels are widespread throughout the lake, and they're filter feeders. So they're siphoning water, they're filtering out the small microscopic food, and each mussel can filter about a quart of water each day. And collectively across all the mussels, they've effectively filtered the volume of the water in Lake Michigan. And as a result, the lake is now much clearer. Anybody who's spent time on Lake Michigan probably has realized this, that over the last 20 years, the lake has become much, much clearer. The productivity of Lake Michigan has shifted, and the food web has changed. And simply put, there's less food out there right now for aquatic organisms, like including fish, to eat. This has impacted the fish, and it has also likely impacted the commercial fisheries. So at approximately the same time that we were seeing this decrease in whitefish biomass out in Lake Michigan, we were also seeing a similar decrease in the harvest of whitefish in Lake Michigan by commercial fishers. So this figure on the bottom shows commercial harvest of lake whitefish. This is across the entirety of Lake Michigan. And again, a similar shift or decline in the harvest. If we look at Green Bay, which is the black bars here, while their biomass was increasing, we saw, I would say, a steady or slightly increasing harvest, commercial harvest of whitefish in Green Bay. So this is just kind of a brief intro or snapshot of some of the commercial data. But for the next part of the talk, I want to specifically highlight the commercial fishery for lake whitefish. So right now, there are about 55 licensed commercial fishers in Wisconsin waters of Lake Michigan. Commercial fisheries are certainly important, both for the fishery, for the local history and culture, for the economy. Some of the common gear types that are used by commercial fishers to catch their fish are trap nets, gill nets, and trawls. This is a trap net. This is a passive entrapment gear used on both Lake Michigan and Green Bay. The fish will basically swim up into the lead, which will guide them then into the pot where they are captured. There's a double flag, an orange flag that marks the lead or the shallow end of the net. There is a single dark flag that marks the pot or the deep end of the net. And you can basically go up to that flag, and the commercial fishers can pull the pot of the net. They can remove the fish from that net and then ultimately process their catch for the day. Another gear that's commonly used is the gill nets. Gill nets are another passive gear that work by kind of entangling the fish within the net. Similarly, each end of the net is marked with a buoy, and you can use different size mesh in your gill net to target different size fish. This is a commercial gill net tug. These are nets brought into the boat with the gill net lifter. So it's a mechanical lifter, so you're not actually pulling the net in by hand. And then the fish are processed. Some commercial fishermen will process the fish in their boats. Some of them will take them back to their fish house for processing. And then a third net is the trawl. This is actually relatively new for that. Trawls are used for Lake Whitefish for the commercial fishery in Lake Michigan. In about 2015, there was actually an experimental study that was done to evaluate the effectiveness of trawls, the bycatch with trawls. That was done with Sea Grant and Wisconsin DNR. And right now we're actually working on a permanent rule for the trawl. They're allowed to trawl for whitefish just in Lake Michigan proper and only within a certain area that's designated for the trawl. The trawl is essentially dragged behind the boat. The otter boards or doors will keep the net open, and then fish will get trapped in the cod end of the net. So this is a commercial trawler. This is a trawl being pulled into the boat, and then this is the catch from that net drag. So whitefish are managed on a quota system. So there are 3 zones within Wisconsin waters of Lake Michigan, zones 1, 2, and 3. Commercial quotas are allocated or renewed annually once a year with their license. Quotas are zone specific, and fishers can actually sell or transfer quota within a zone to other fishers. For roughly 30 years, the fishery was managed with 1 quota, and that quota was split among the zones with roughly 10% going to zone 1, 80% going to zone 2, and about 10% going to zone 3. Recently, we actually shifted to a 2-stock management and quota system. So quotas are now set based on the statistical catch-at-age models that I showed previously, the results of biomass for Lake Michigan and Green Bay. Those results are used to set the quotas for the commercial fishery. Right now, Lake Michigan has a quota of about 874,000 pounds for whitefish. Green Bay has a total quota of about 2.28 million pounds, and that quota is actually split 50-50. So the commercial fishers take half of that. So right now their quota is about 1.14 million. The other half is retained with the expectation that there's opportunity then for sport anglers to go out and harvest that quota as well. So just like a sport fishery, there are rules and regulations for the commercial fishery. The commercial fishery has a length limit of 17 inches for whitefish. There's a season closure. In November, the commercial fishery is closed to help protect spawning whitefish. There's refuges and closed areas. There's gear specifications. Similar to sport regs, have a 10-fish bag, 3 fishing lines open year round. Similar to charters and guides who fish for the sport fishery and are required to report their catch and their effort. There's also a mandatory reporting system for commercial fishers. So historically, the reporting by commercial fishers with their catch and their harvest was done with paper forms. They were required to submit a record once a month. Recently, that switched to an electronic fish harvest reporting system. So I actually pulled this from the electronic fish harvest reporting system last night. So as of yesterday, there was actually 3 different effort entries entered for commercial fishermen that are currently out fishing. And within the system, if you click on export data, you will get a spreadsheet that shows you the license number, the boat name, the port name, the date caught, where it was caught, the depth caught, net nights, species, all the information that they're required to submit. I pulled this. This is a snapshot of some of the data from the commercial fishers that were out yesterday. So there were, I think, 11 lines of data here. One fisher was fishing gill nets on the bottom out of Sheboygan. Another fisher yesterday was fishing gill nets out of Egg Harbor through the, and then all fisher in Two Rivers was also out fishing yesterday for whitefish. So this is real-time data. It's real-time results. With anything, I think there were some challenges and learning curves with figuring the new system out, but it's designed to hopefully make it easier for commercial fishers to report. And it also makes it easier for us in the department to receive that information and have it available to use. And to summarize, like we see here. So what this is commercial harvest in Wisconsin waters of Lake Michigan for trawls, gill nets, and trap nets by the different colored bars. And overall, we've seen a decreasing trend in Wisconsin waters. So the previous I showed was throughout all of Lake Michigan. This is just Wisconsin waters of Lake Michigan. And similar to our reduced biomass of whitefish, we're seeing a similar trend with the reduced catch or harvest of whitefish. If we look at Green Bay, so this is Wisconsin waters of Green Bay, gill net and trap net harvest. And we see an increase in the trap net harvest in Green Bay. Again, closely resembles the increase that we've seen in biomass in Green Bay. And if we just do a quick side comparison of those two, Lake Michigan on the top, Green Bay on the bottom, one of the big things we've seen is a shift in the trap net harvest from Lake Michigan to in Green Bay. We've also seen since 2015, this new trawl fishery that's now taking place on Lake Michigan. And that addition of the trawl fishery has likely accounted for some of the reduction that we've seen in effort from particularly gill nets in Lake Michigan. So if we add both of these together, we can look at the overall whitefish harvest through time in Wisconsin waters of both Lake Michigan and Green Bay. We've seen a slightly decreasing trend over the past 20 years, but it's still around the long-term average, and it's actually below quota. So the black line going up and down, that's actually the quota that the fishers have available to catch. So this figure shows commercial harvest, all gear for whitefish. Next, I want to look at effort. I'm going to look at effort specifically for trap nets, which is going to be expressed in the number of trap net lifts. So this figure is for Lake Michigan and Green Bay, Wisconsin waters. This is trap net effort in the numbers of lifts for Lake Michigan in the black, Green Bay in the yellow. In 2023, we had about 1,400 trap nets that were lifted on Green Bay, or trap net lifts. And we had about 250 trap net lifts on Lake Michigan. So a lot more lifts on the bay. Overall, Lake Michigan, we've seen reduced trap net effort. Green Bay, we've seen increased trap net effort. Next, I'll show the gill net effort. And this one's going to be expressed in millions of feet of gill net. So Lake Michigan and Green Bay, gill net effort, Lake Michigan in the black, Green Bay in the yellow, both generally decreasing. And again, decreased effort by gill nets has somewhat been replaced by the trap net effort in Green Bay. And in Lake Michigan, there's been some additional with the trawl. So I have just one more slide that I'm going to show with commercial data. And it's going to be on fish size, Green Bay versus Lake Michigan. So these figures show, this is from trap net harvest, commercial trap net harvest of whitefish. This is for 2 years of data. So at the top, we have 2015. The bottom, we have 2017. Locations are Green Bay in the white and Lake Michigan in the black. And this is a length frequency of whitefish sampled. So the higher the bar, the higher the number of whitefish that we caught or that were in that particular size range in that sample. And then the red line just references a 20-inch whitefish. These are in millimeters. So just to give you some reference, the red line is a 20-inch whitefish. And generally, we're seeing smaller, younger whitefish harvested in Green Bay. We're seeing bigger and older whitefish harvested in Lake Michigan. So how are the whitefish populations doing in Lake Michigan? It really depends where you're looking, with two very different stories for Green Bay versus Lake Michigan. So next, I just want to very briefly highlight the sport fishery, and then also talk a little bit about some DNR surveys that are conducted for whitefish. So I mentioned earlier, we saw an increase in the fall observations of lake whitefish in the Menominee River in the electrofishing surveys in about the 1990s. We saw an increase in commercial trap net effort in Green Bay in the early to mid 2000s. And in about 2007, we saw the onset of a sport ice fishery for whitefish in Green Bay. It kind of came out of nowhere. This is an ice fishery on Green Bay. It's supported by like individual recreational anglers as well as guide fishers. And the red line here is angler effort. So from our Creel surveys, we get estimates of how much effort was actually put into anglers going out to fish. And then the bars are the number of whitefish actually harvested. So we generally saw a decrease in angler effort fishery through the 1990s. And this was partly due to a declining yellow perch fishery. And subsequently, starting in 2007, we saw this huge resurgence in ice fishing effort, mostly due to targeted effort and harvest of whitefish. This peaked at over 300,000 whitefish or angler hours in 2021, and it peaked at over about 200,000 whitefish harvested by ice anglers in 2018. We have seen a slight decrease in both harvest and effort in recent years, especially in 2023. This year, ice fishery is reliant on ice, and last year we didn't have much ice. So I think that's partly why we saw this trend last year. I'm excited to see what it looks like this year now that we've had a relatively good year for ice, at least so far. So this Creel survey and a lot of the information that I presented, the commercial reporting, the commercial monitors, the guide reporting, those are all fishery surveys. So we rely on commercial fishers or anglers to collect and provide information to us. But at the department, we also conduct fishery independent surveys. So these are surveys that are conducted with our DNR staff, with our DNR boats. 8 other agencies also collect these surveys. And I just want to real briefly highlight some of the work that we do. So targeting whitefish, some of our base, we look at both the open water as well as the tributary systems. We sample with gill nets, electrofishing, trawls. We sample at different times of the year. So trying to get a handle on different life stages of whitefish and what's going on in those populations. And we've also recently done some pretty neat work with tagging studies. And this is the one and the last set of information that I want to highlight today. And that's on some of these efforts with tagging whitefish. So I've talked today about differences between Green Bay and Lake Michigan. So differences in biomass, harvest, effort, size, quotas. I've talked a little bit about our quota system that's managed based on these different zones. We actually have some recent evidence that evaluates kind of the genetics of the whitefish, and actually suggests that there's, I would say, 3 big, maybe 4 or 5, like genetically distinct populations of whitefish that are essentially not mixing or breeding with each other. So, fish swim, right? So do they move from Green Bay to Lake Michigan? Do they swim from zone 1 to zone 3? We've had a pretty big paradigm shift in the way we manage whitefish recently, where we went to this 2-stock system where we're managing for both the Green Bay population and the Lake Michigan population. So trying to understand how those fish move throughout the lake is potentially pretty important to help inform our management decisions. So I want to give a big thanks to the Wisconsin Cooperative Fisheries Research Unit with UWSP and the USGS. They've done a lot of this research. There's been commercial fishers that have been involved in helping to tag some of these whitefish. Several Wisconsin DNR staff have spent a lot of time tagging these fish. It's been a very big effort. And really, there's actually a lot of pretty cool research going on right now with whitefish. Several of those studies are here. Fisheries biologist Scott Hansen is a cooperator on almost all of these projects, so he's been real busy doing a lot of good work with these as well. And the three that are highlighted are three major projects that are ongoing right now. So otolith microchemistry work, latent mortality of whitefish in Green Bay as they're released from both the commercial and the sport fishery, and then an acoustic telemetry study, which I'm going to highlight right here. So this shows, let's see here. This is the locations that whitefish were tagged in 2017 and 2018. Crews went out and we tagged these whitefish while they were spawning. So a lot of these fish were sampled in the rivers. Some of the fish were sampled out in the lake. There was actually a commercial fisher. The commercial fishery is closed in November, but he set trap nets in the lake specifically to help with this study. And then we used, or several, I shouldn't say we, I didn't do much of this work, but the cooperators used two different tags, acoustic tags and then loop tags. So there were about 400 fish that were tagged with acoustic tags. There were over 8,000 fish that were tagged with loop tags, as designated with the numbers here. And then we can use those tags to get information on how those fish are moving in the lake. So there is a acoustic telemetry array set up out in the lake and the bay. The initial design had, so there was these sets in the lake. There were several arrays set up in the rivers and the tributaries. And basically they will detect a fish if it's tagged as they're swimming past it. One set of arrays was on the line with Chambers Island. So if a fish were to move from northern Green Bay to southern Green Bay, it would pass the first line of arrays. It would then pass the second line of arrays. So it's important to have two so that you can get direction. If you just had one, you wouldn't know whether they're swimming north or south. But if they have two, you can look at the times that they cross the first line, the times that they cross the second, and you can actually figure out which direction those fish were moving. We had another array that was set up by Washington Island, basically evaluating whether fish are moving from Green Bay to Lake Michigan or vice versa. So in the Menominee River, there were 97 fish that were tagged with these acoustic tags. 47 of them crossed that Chambers Island line. So a relatively large amount of fish were swimming from southern Green Bay to northern Green Bay, but there were only 5 that actually left the bay and went out into Michigan. So Menominee River Lake whitefish, they tend to stay in Green Bay. They rarely move out to Lake Michigan, but there are some, maybe 50%, that will swim north within the bay. North Moonlight Bay, so this is in Michigan. There were 32 whitefish tagged with these acoustic tags. Only 6 of them were detected going into Green Bay. Of those, there were 3 that were detected going south into the bay. So northern Moonlight Bay fish tend to stay out in Lake Michigan with relatively low numbers swimming into Green Bay. So the initial phase of this project used this line for the receivers, and then it recently transitioned to a grid design. So now there's all these different receivers that are being placed out throughout in this more grid design. This portion of the study is going to focus on southern Green. The goal is to tag about 300 fish from both the commercial and the recreational fisheries. This has already started, but it is ongoing. And so far, data from both the loop tags and the acoustic tags seem to show similar results. Generally, whitefish seem to stay home. There's relatively limited far distance movements by these fish. So in summary, the current status of lake whitefish stocks are very different when you're looking at Lake Michigan versus Green Bay. Green Bay has a higher biomass and stronger recruitment with relatively high, but I would say deep biomass over the past 6 years. Lake Michigan is very different. We've seen decreasing biomass of lake whitefish across the past 18 years. We're seeing bigger and older fish, And there's evidence of limited or failed recruitment years, which partly is why we're not seeing many of those smaller fish in the system. And we see similar trends pretty much across Lake Michigan proper, as well as Lake Huron with whitefish. The commercial and sport harvest and efforts in southern Green Bay have generally increased. So the commercial harvest commercial program has increased trap nets in an effort in Green Bay. The sport ice fishery ramped out about 10 to 15 years ago, and that supports both guide and independent anglers. And we've also had this paradigm shift. So we now, rather than managing for one stock in Wisconsin waters of Lake Michigan and whitefish, we now have 2 population models, and we're essentially trying to use the data, the information, the science that we have to more effectively manage the population for what's happening in Green Bay and what's happening in Lake Michigan. There's a considerable amount of research going on right now with lake whitefish, and I would say 2 kind of ongoing priorities with the research is to look at latent mortality in both the commercial and the sport fisheries. So after those fish are released, are they surviving? And then there's also some ongoing priorities to try to look at and find and evaluate different spawning locations for whitefish throughout Green Bay. So that is all that I had. Again, I want to thank Mark for inviting the Wisconsin DNR to be here. And if there's time, we can take any questions.
Let's give them a round of applause. What I saw just a few days ago. Hello. Button's on. Where is it on?
Yeah.
This one's not reverberating.
Press button.
I got the button on. Hey, see, I got the button. Hello. Hello. Maybe it's a different set. No, not that one.
Is this one working?
Yeah. Well, if that one's working, this one should work. Oh, well. I know Nick put a whole lot of effort into this. In addition to Scott. So, question. With the, oh, you gotta get a microphone.
You were talking about the zebra mussels being an invasive species and they're increasing due to being on the ships and such. Is there anyone trying to make a dietary use of them? Are they edible? Is it something that these commercial fisheries could pursue as an idea to take down that population?
So, like from a fish perspective, fish do eat mussels. Whitefish will eat mussels. I actually did my graduate research on Lake Erie, and that was one of the like in terms of diet biomass, yellow perch, freshwater drum. I mean, I saw fair numbers of mussels in their diets, but I think the problem is they're just so widespread. I mean, so initially zebra mussels were the invasive mussels, and they tend to inhabit shallower waters of Lake Michigan. Now it's actually quagga mussels that are the dominant mussel in Lake Michigan. They look very similar to a zebra mussel, but quagga mussels can inhabit the deep waters of Lake Michigan. So like they're widespread right now throughout the lake. So fish will eat them. I know there are some efforts to like look at different control options for mussels, but I'm not that familiar with them. And I think one of the biggest challenges is it's such a big area. Like, how are you going to effectively do anything about it? But there are some things being looked at and researched. In terms of like consumption, like I don't know if I can't really speak on that. Like in terms of harvesting them for consumption.
Well, they're not very big.
Yeah.
Take mussels to make soup. Other questions up here?
So on the chart that you had where you showed the amount of biomass in Green Bay and then Lake Michigan, and then you showed the quota, you showed an increasing quota, but yet there's a decrease biomass. I'm
Yep.
confused as to why the quota doesn't more generally reflect a lower number due to the lower biomass.
So, let's see, gonna see if I can go back to that slide. There it is. So this, and I cannot recall all the details between exactly the quotas are calculated with the models. But I do generally know that, so it's every few years, the models are run and the quotas are updated. And that it's relatively new. So using these models to set the quotas is a relatively new practice. And it'll set a quota for Lake Michigan as well as the Bay. So what you're seeing here is the total. So this is the total quota for Lakes Michigan and Green Bay. But I don't know for sure how to best answer your question. I know there's been some, I guess, oddities with like the size of the fish. Like there's relatively old, bigger fish in Lake Michigan right now, and I think that may have had some impact on how the quotas were set. But I wish Scott was here to answer that one. I'm not really certain.
How many years have they actually done the
The Lake Michigan or the Green Bay model is relatively new. Where is it? I want to say it was the mid to late 2000s that we have data to update that one. But I mean, some of the data, like on the Lake Michigan model, I don't know when exactly we started running the models, but I mean, we utilize historical data to populate the model. So it goes back farther. But it's fairly recent, within the past several years, that we've started actually using the models to set quotas. And that's actually that's in code or law now, that we set the quotas every few years based on the model results.
One question.
What is agricultural runoff? It seems like the mussels clean the water up, there's less food in the agricultural runoff, makes it dirty, so they're making more food. And with these CAFOs, you know, they concentrate on agricultural feed regulations. Is that interplaying with the mussels and the whitefish and the gobies? So agriculture.
Sure. I believe it's the chemistry behind it is more complex than, you know, let's dump a bunch of agricultural runoff into the lake and increase productivity and out in the lake. So I don't know all the chemistry behind that. I think it's more complex than stated. But I mean, you see the differences between Green Bay and Lake Michigan. You know, Green Bay is a shallower, warmer system. There is more impact from some of the nutrients in the dumping into Green Bay. And I mean, you see that. You see more productivity in the bay itself. But the lake is just a different story, deeper, cooler, and the mussels have effectively filtered a lot of those lower trophic level food sources out of it. They're not gone. The energy is still there, but instead of being pelagic and in the watershed, you know, a lot of that energy is now tied up in mussel biomass on the bottom of the lake. So I don't know that really answers your question, but
Well, it is a tale of two stories, right? The lake's different than the bay. And likely the productivity in the bay is related to all the nutrients. So to me, it's a conundrum. If you achieve some of the phosphorus goals and so on in like Green Bay, Michigan, where the phosphorus is lower, is it going to lower fish production then? And I know a year or two ago we had Dr. Val Klump from UW. He studies that kind of stuff in Green Bay, and I asked him that specific question. I said, what if you lower the phosphorus inputs in Green Bay so much that it turns into Lake Michigan? Is that what you want? And he says, no, I think there's enough phosphorus still coming into the system, that if you decrease it a fair amount, you still would have enough to support the fish. Now, that's what knowledge is telling the fisheries guy, and we'll have to see. But kind of a conundrum. Why isn't Green Bay looking like Lake Michigan? It's because of all these nutrients coming from tributaries, on point stuff. So it's an interesting thing to tackle.
Nick, can you just review the spawning patterns between the lake and the bay of the whitefish? Like, you mentioned the whitefish are spawning in the Menominee River versus in the lake. How deep are they spawning, and what do they like? What do they like for the bottom? Can you just review that?
So again, I don't know the specifics of the depth and size of the substrate and things like that, but generally they're spawning on rocky substrate. So in the tributaries, they'll run up into the rivers and find rocky areas to spawn. Out in the lake, they'll spawn on like rocky shoals and reefs and things like that. So I presume areas where it comes up a little bit on the shoal or the reef. We don't know. I mean, there's a lot that we don't know about whitefish. I mean, one of our research priorities right now is to investigate that and try to find areas throughout Green Bay where they are spawned. There's historical areas in Michigan, like Carty's Reef up in the lakeside of the peninsula that we annually set gill nets on in the fall. But there's got to be a lot of other areas too. I mean, I was at a meeting with the Fish and Wildlife Service a couple of weeks ago, and they have been doing a lot of work reef mapping and doing different studies on Larson's Reef. And they've documented eggs on Larson's Reef that they're not 100% certain, but they're fairly confident are probably whitefish eggs. So yeah, there's probably a lot of areas out there that we still have to learn about.
And related to that is a lot of people think that it's the rivers that are supplying most of the whitefish to the bay. But based on the latest information I'm hearing from Scott and Nick and others, they have sampled larval fish in the rivers, but the amount of fish that they get can't be enough to support the increase in biomass in Green Bay. So therefore, they must be spawning in other areas that we just haven't experienced before.
One more question. Yeah, Lake Superior, they've been pulling, whitefish in here and through the ice for years and years, but are they, the guys out of Egg Harbor, has that been an ongoing thing? Have they been fishing through the ice commercially, pulling nets through the ice commercially for a long time?
Yeah.
Okay.
Yeah, I think the answer is yes. And some of the commercial guys, I think Charlie's on the Zoom, but there's been ice fishing for whitefish in Green Bay for quite a while. It may not have fluctuated, but yes. Commercial fishing. Commercial fishing.
And then just as recent as 25, just this winter.
Yesterday.
Yesterday.
Yeah.
So the harvest, did they?
I can't recall what the harvest was. But yeah, last night when I was preparing for this, I logged into EFERS and checked it. There was a report of gill nets being fished through the ice. Yep.
Bear with me, I do have a question. So the gobies numbers have gone as an invasive species, and quagga mussels have gone invasive species. Whitefish have evolved now to eating those both. So everything I said, is that all correct? Okay, so if they're eating the gobies and they're eating the quags, and there's tons of both of those out there, not enough to support a larger population of the whitefish?
I mean, I think a lot of it just depends on like the energy density of those different prey items. And off the top of my head, I don't know. Diaperia historically were the primary and the native food source that whitefish relied heavily on. And I mean, I generally know that whitefish were a very high energy prey. How does that relate to a mussel or a goby? Off the top of my head, I'm not certain. It's a different prey type, but whether it's going to completely that niche or that gap, I mean, it seemingly hasn't. But yeah, they're definitely consuming them.
So, in my experience, and a lot of it's been with some of the tribal fisheries. And obviously with all the mussels that are in Lake Michigan, the whitefish aren't doing well, they're not a good food source. They can't sustain themselves on mussels at all. Plus you have the added complexity of the mussels filtering the water so much that this whole plankton and phytoplankton have changed significantly. And as Nick mentioned, the fish in the lake are getting older and older and older, which is not any recruitment, no survival of juveniles. And that's where they really get hit. That's the same thing with yellow perch in Lake Michigan. They're greatly reduced and they're getting older because there's not good recruitment, because that phytoplankton and zooplankton are there for the young fish aren't there because of the filtering of the mussels. Now the gobies, I think that's one of the shining whitefish, shining things for is that they have the gobies, that they don't have to rely solely on dichromaria. So that's my perspective.
And just to elaborate on that a little bit, and don't quote me on this because I'm basically going off memory from a conversation I had with Scott yesterday, but it seems that growth rates are slow right now in Lake Whitefish, regardless of whether you look at the lake or the bay. It differs depending on like the ages of fish, and it might be particularly the younger fish. Like there's certain younger fish that are maybe growing better in Green Bay, and that might be partly why we're seeing better recruitment in Green Bay. So for a small larval fish of any species, like that early life stage is really critical. They need to be able to find food, eat food in order to make it over that hump and recruit and survive. So there may be better opportunity in Green Bay for those younger fish to survive, which is partly what maybe seeing better recruitment in Green Bay. Whereas in Lake Michigan, you know, we're not really seeing that food source to get them over the hump. So we're not seeing as much recruitment in Green Bay. But once those fish get older, you know, we're seeing relatively slow growth right now, regardless of where you look, Green Bay or Lake Michigan.
Other questions? So part of the take-home message from what he just said, and that since I talked to him yesterday, while this boom in Green Bay, thank God it's there for whitefish, or else, you know, you had to rely on Lake Michigan to support fish boils, it may not work, right? But even in Green Bay, as good as it is, it's slowing down. So we got to make sure that we stay on top of it, or they stay on top of it, so that it stays well. But with a lot of gobies and stuff out there, and the nutrients, it's not looking as dire as Lake Michigan. But yeah, actually, to prepare for this, I actually called some of the people that I work with on tribal fisheries. I said, "Is it really dire? How dire is it?" Well, it's pretty dire. You consider in Michigan waters, in the lake proper, you know, their whole harvest last year was 130,000 pounds. That's the whole shoreline of Michigan. You know, they're just not. So we should be happy that we have Green Bay, and most of the lakes, Green Bay is the highest population of whitefish in all of the Great Lakes.
In all of the Great.
Well, yeah, for that region, yeah, the production of whitefish in Green Bay is as high as it is anywhere.
As we see the increase of whitefish population in the bay, has it affected the other species? Walleyes, perch in the bay? As the whitefish population grows, are the other ones declining?
So I haven't looked at that specifically, but just trying to think through it. mean, whether it's an invasive species competing with native species for limited space, limited resources, or whether it's a native fish population competing with other native fish, they certainly will compete with each other. So, you know, whitefish, again, are generally benthic. They're eating a lot of invertebrates, gobies, mussels. So yeah, they will compete with other fish, but it's had a direct effect on the abundance and biomass of other fish species. I would have to try to tease that apart by looking at the data. Off the top of my head, I'm not certain. You have any thoughts on that?
Does the DNR do research on the other species in the lake and then compare them?
Yeah, so like out of the Sturgeon Bay office, Scott specializes in whitefish and smallmouth bass. So we conduct smallmouth bass surveys annually. Tammy Paoli out of Peshtigo, she specializes in perch and northern pike for the bay. Jason Bregeman down in Green Bay specializes in walleye. Yeah, we're